this question, we have an object with a known mass traveling toward a wall, and it collides with a wall. So here's our wall, and let's make our object like this. It has a mass m with a v0, travels toward the wall, collides and bounces off the wall with an object it was initially traveling. So that's afterward. We need to use the equation delta p equals F delta t to determine the change in momentum of the object immediately before the collision to immediately after the collision. Which side of the equation could the student use to determine the change in the object's momentum? So if we want delta p, which is F delta t, it is also equal to m delta v. So delta p is m delta v. So if we want to use the delta p side, we know the mass, but we don't know the change in velocity. We know that we're given some velocity v0 and has some velocity afterward. But we don't know anything about the velocity afterward. This is unknown, so we don't know delta p. And so it is true, we know the mass, we know the initial speed, but that's not enough because it's mv minus v0. We know this, we know this, but we do not know this, so we cannot find delta p. So this one's out. In terms of the second question, we are told that there is an average force F0. So if we want to use the other equation, F delta t, which is equal to the impulse, well, we know F. We don't know the impulse. We don't know the impulse, and we don't know the delta t. So there are two unknowns there because the average force exerted on the object is known. Well, if the F is known, that's not enough. There are still two unknowns. So this one is out. It says either side. Well, what we know is neither side can. So that's false. This would be correct if these two were both correct. If both of these, then this would be the answer. But since neither of those, it is not this one. So neither side can be used because there are too many unknown quantities before, during, and after the collision. And that's the answer.